We're going to get started now. The topic for today is 4 things to do before every flow simulation analysis. My name is Terrence Wu. I'm an applications engineer here at Hawk Ridge Systems, and I'm based out of our office in Richmond, British Columbia. With me, I also have Damon Tordini, one of our simulation specialists, who'll be helping answer questions. The goal for today's webinar is to go over some key things you should do before every flow simulation analysis. We find that taking these steps before starting your simulation setup can save a lot of headaches and a lot of time. One of our analysis services engineers, Chris Ma, wrote a blog post a couple of years ago which included 4 things to do. And these 4 things are to run forced regeneration or forced rebuild with the verification on rebuild option turned on. Check your model geometry using the check entity tool. Check your model geometry using the flow simulation check geometry tool.
What is SOLIDWORKS flow simulation?
And use interference detection. And sorry guys, looks like there's a little bit of feedback. Just going to see if I can get rid of that for you. Okay, we should be good there. So yeah, these are the 4 things that are good to do before you start any flow simulation analysis. However, I actually think that there's a few other items that are very important as well. And so I'm going to change the title of today's webinar from 4 things to do to 7 things to do before every flow simulation analysis and cover 3 bonus items. The extra items that I want to talk about are using import diagnostics, creating lids, and using the leak tracking tool. So, with all that said, let's get into it. I'm going to be working with this model here. It's a little electronics box. I'm sure some of you have probably seen this before, right? Pretty simple. We've got some different electronics components, and we're going to run a thermal analysis on it. Now, I'm not actually going to get into flow simulation and running any analyses, right? These are the 7 things that you want to do before you start your simulation setup. So I'm really still just inside my regular SOLIDWORKS interface. And the first thing I'm going to do is that forced regeneration with the verification on rebuild option. Now, if you aren't familiar with this, you'll want to go into your SOLIDWORKS options, and under System Options, Performance, we're talking about this option up at the top. Now what this verification on rebuild option does is it enables advanced body checking. Basically allows SOLIDWORKS to do a more thorough check of the faces and geometry when it's doing a rebuild operation. So I'm going to check that on, click OK, and now I'm going to do my forced regeneration by hitting Control Q. Now, forced regeneration is sometimes called a forced rebuild, same thing. And the contrast between a forced regeneration, forced rebuild, Control Q, and your regular rebuild up here, which is Control B, is that this regular rebuild tool, it thinks it's smarter than it is sometimes. It tries to track what's changed since the last time you did a rebuild and then only rebuild those items. And a Control Q doesn't do that. It just rebuilds everything. And so you're going to make sure that your model geometry is up to date. So I just hit Control Q, and that's it. I can come back into my options now, go into performance, and I can turn that option off. Having it off will make your rebuilds a little bit faster, improve your performance. That's why it's off by default. Really, it's not a massive difference, so a lot of times I'll just work with it on. There's no strong disadvantage. Now, most of the time, you shouldn't see anything weird pop up when you do that Control Q. The main thing that you're doing is making sure that your model geometry is up to date. However, there are instances where you can get errors or warnings, and those will be very obvious. You'll see yellow and red in your feature tree, and then you can go and fix those. Now, assuming that's all good, we get to move on to our next step, which is using the Check Entity tool. And you can find the Check Entity tool by going to Tools, Check. And what we're looking to do is we're looking to find any faces or edges which are invalid. It's pretty rare to encounter this if you're creating your models in SOLIDWORKS, but it can happen sometimes, and it's a little bit more frequent for this to actually pose a problem when you're working with imported bodies. Really easy to use, simply just hit check, take a look at the message. If there are any problems, it'll let you know here. You'll have a result list and it'll highlight those. Now again, most of the time this isn't going to spit anything out. It's just a good check to do. And so we're happy here. We can close that out and continue on. Now the next thing I want to do is I want to use the interference detection tool. Most of you have probably used this before. On the Evaluate tab of your assembly, you can go to Interference Detection, and it's going to check your model for any overlapping material. Now, interference isn't necessarily a problem when you're going to flow simulation, but it is important that we're aware of where these interferences are, and then we can decide whether it's a problem or not. Now, the one option you do want to make sure you have on if you have multi-body parts is this include multi-body part interferences, and then simply hit calculate, and it'll spit back any interferences that I have. Now I can see I have a whole bunch of overlapping interferences. They're all the same volume, and looks like these chips are intersecting with the circuit boards that they're mounted on. Now again, this isn't necessarily going to stop our flow simulation from running. If we're just looking to analyze fluid, it's fine that a little bit of solid is overlapping. However, if I'm looking to do a thermal analysis, well, it might be a little bit more of an issue. Is that overlapping area, or is that overlapping volume supposed to be the material of the chip or the material of the PCB? And it looks like in this case, this wasn't actually intentional. So I'm going to go and modify my model to get rid of the interference and then check that that's all fixed. Now, knowing how this thing's put together does help, and I think the problem here is just one of the mates where I've grabbed the back of the chip instead of the bottom of the feet. So to fix that up, let me just hide away this component here, and I'm simply just going to edit my mate to use the bottom of the foot instead of the back of the chip. So that should fix it for the one part there, and I'll do the same thing over here for this chip. And of course the fix for your interference is going to be different depending on what your model is, but just want to poke through, decide whether it's a problem, and make any changes that are necessary. Okay. So that should help clean things up. I can bring those two parts back now. And let's just double check that I fixed that properly. I'll run interference detection again. And oh, looks like I didn't actually fix it properly. So let's go have a look. And what I need to do here is I need to rebuild my model, make sure everything's up to date. So again, just gonna rebuild, do one more check, and this time I have no interferences. Perfect. So we've gone through Control Q with verification on rebuild. We've talked about the tools check, and we've done interference detection. The first bonus item here that I want to jump into is that import diagnostics tool when you're working with imported bodies. This heatsink here, I've imported this from an IGES file. And when you import items, it's pretty common for there to be small errors. And the easiest way to identify whether or not this is going to be a problem is to right-click and run something called import diagnostics. When you import a part for the first time, SOLIDWORKS will actually prompt you and ask you, do you want to run import diagnostics? I always recommend hitting yes to that. It'll run through a check, and if there are any faulty faces or gaps, it'll let you know. And so what's happened is this end face simply hasn't linked itself to the rest of the model properly. Typically, if you hit attempt to heal all, SOLIDWORKS will be able to fix the problem for you, and it's as easy as that. If SOLIDWORKS can't fix the problem, you're off to surface modeling. It's a whole other can of worms, but you can give us a call for support and we can give you a hand with that. Most of the time though, hitting that button should do everything you need it to. Click OK. I can save this file, and that's fixed up by imported body. Okay, so that was the first bonus item. Second bonus item that I wanted to talk about was creating lids. And this is something that we do before we go and start our analysis, but it's definitely a necessary part if we're going to be running an internal flow simulation. And there's two main ways that we can go and create lids. First way is to use the Create Lids tool in SOLIDWORKS Flow Simulation. I'm sure many of you have used this before. It's pretty simple to use. Just going to grab the tool, go and click on a face or two, and it'll create some lids for me. And so I can see in my feature tree here, I now have 6 lids for my 6 holes. The other main way that we can go and create lids is to do it manually. Right? And usually that involves either creating a new body in a part file or a new part in an assembly file. And so I'm just going to use my Convert Entities tool and grab these guys up here. Oops. There we are. Just use my Convert Entities tool, copy the edges of those holes, and then simply just extrude. And so that'll give me another part there with a couple of lids. All right, so two main ways, using the Create Lids tool or manually doing it. Obviously, creating the lids manually is a little bit more work up front. However, this is typically the way that I like to do it. And the main reason is because I now have lids which are parametrically linked to the model. The limitation of the Create Lids tool is that it creates non-parametric lids which aren't fixed in space. So you can run into a bunch of problems here. Just going to switch this enclosure back to transparent and make a couple of changes, and we'll see what happens here. First off, if I go and change the size of the hole, just grab that hole and make it larger, my lids now no longer fill the hole. So obviously not the greatest thing. Set that back. The other problem here is if I go and I start moving those features, those lids don't move with it. Whereas you can see the lids that I created on top do update with the model. All right, so definitely going to be a more robust solution to create them manually, although it is a little bit more work up front. And I'll just go back and clean that up. Now, the last problem with the Create Lids tool is that they are floating in space. And so if you accidentally grab one of them, you can pull it off and slide it away. So you just want to be very careful when you use that tool. It is very quick though and easy to use, so if you're looking for a quick solution, definitely don't use it. Just be aware that it can move around on you and it won't update with your model. Now, creating it manually is the way I like to do it, but there are certain things you need to be careful of. When you grab the existing geometry using Convert Entities, you want to make sure that these sides are straight. If they're on an angle, you can end up with zero thickness geometry. And SOLIDWORKS flow simulation is not going to like that. So if you do have a simulation where you don't have straight walls, you have an angled hole, you'll want to overbuild. And what I mean by that is create your new extrude feature, your new lid, larger than the hole itself. It's okay if there's some interference and some overlap of material. You just want to make sure that you don't end up with a zero thickness condition. The other way that people end up with a zero thickness condition, and this is really common, is actually just extrude the wrong direction by accident. And so if I do that, I'm going to end up with zero thickness along these edges here. Now, let's say you go through, you create these lids, and you mess up. You don't spot these problems. How do you find out about that? Well, going back to the third item on the original 4-item list is the flow simulation check geometry tool. The flow simulation check geometry tool isn't going to check for invalid edges or faces. Instead, it's going to be looking for the fluid volume that flow simulation will be using and trying to identify any problems with that. It's still very easy to use. You simply launch up the tool. I'm going to tell it I'm going to do an internal analysis, hit check, and it'll take a look at your geometry. And it'll spit back any problems. And so we get some different pieces of information. First off, it failed. It tells me I have a non-watertight model. Right? If I want to do an internal analysis, I need to have the entire volume closed. It also has some zero thickness curves lines, right? And as I click on these, you can see they highlight, and it's simply that I've taken my lid and extruded it in the wrong direction. So a great tool to use. It can help you identify these problems before you get too deep into your analysis setup. Now let me come back here and close the tool. I'm going to fix my extrude so that that's no longer an issue. Just flip that direction back down into the part. And let's check that again. So flow simulation, check geometry, internal analysis, hit check. Runs through again. This time I don't get the messages about the zero thickness contact, so that has been fixed, but it still says that I have a non-watertight model. Okay, so what do we do in this stage? Well, we can look around our model and try to figure out what's wrong, but often with complicated models, it's hard to see where the problem might be. Is there a tiny little hole in the case somewhere? What am I missing? And so the last bonus item that I want to talk about is the leak tracking tool in flow simulation, which will help you figure out what the problem is when you have a non-watertight model. You'll find the tool under Tools, Flow Simulation, Tools, Leak Tracking. And the way this tool works is you need to select two faces, one on the inside of the model and one on the outside of the model. Which face it is doesn't really matter, just one on the inside, one on the outside. So I can browse out here and take a look at my model. Let's say I use this one on the inside. The Select Other tool can be very handy here. And so you can see I've got one face on the inside, one face on the outside. And I simply hit Find Connection. And what the tool is going to do is it's going to trace a path along the faces of your model and try to figure out how it can get from the inside to the outside. You'll notice there are two colors, blue and red. And the easiest way to use this is to take a look and spot the change in color. So it's on the inside face where it's blue here, it's moving along, and then it switches to red. And so I can see my problem area is clearly here. And remember, I accidentally grabbed that lid and slid it out of the way. And so that's why I have a non-watertight model. And so I'll close up leak tracking. I need to fix this lid. I'd probably model it manually, but for now, let's just drag it back into place. think that looks good. We can double check it by running that leak tracking tool again. Looks like it's still open, so a little gap at the bottom here. So I can go through and try to fix that again. And maybe at this point, it might be easier if I simply just get rid of that lid altogether. Let's just delete that. And let's do it manually. Okay, so I should have a watertight model now. Let's do one last check here. All right, I can do that leak tracking tool, or I can use the flow simulation check geometry tool, either way. Do one check. All right, successful. Geometry is okay. So we've gone through 7 things to do for every flow simulation analysis. All right, we want to start off with that force regeneration control Q, making sure we have that verification on rebuild option turned on. Mostly we're looking to just update our geometry, but sometimes we will find errors and warnings at this stage. We're using the check entity tool under tools check to find any invalid faces or edges. We're running interference detection, making sure that we have our model built as intended. We're using the import diagnostics tool for any imported bodies, whether those are STEP, IGES, ACES, any other file type. Great idea to run that. Talked about 2 different ways to create lids, using the create lids tool or doing it manually, and a couple things to watch out for in either case. We use the flow simulation check geometry tool to make sure we have a watertight model and we don't have any of those 0 thickness conditions. And then we found problems using the leak tracking tool. So if you go through this list before setting up each and every flow simulation analysis you do, and the key there is really to do it before you launch up the flow simulation tool, right? Didn't even get to that stage yet in this presentation. These steps should help save you some time and definitely some pain. Thanks very much for taking the time to attend today's webinar. I hope you found this information useful. We do have webinars every Wednesday at both 10 and 11, the earlier one being a product demonstration and then 11 being a product education session similar to this one. These are the topics for the next few weeks, and you can always find the schedule on our website, hawkridgesys.com. Finally, if you have any questions about anything we've covered today, we're going to keep the session open for another 5-10 minutes. We will answer them. Or you can always contact our support team, phone, email, or through our website. And so yeah, that's it for our session today. Thanks again for attending, and we will keep it open for another 5-10 minutes to answer any questions, so feel free to shoot those through.